welcome back to the IEEE MNSU Podcast. I'm Selena.
I'm the officer.
I'm Connor. I'm a junior electrical engineering and math student and IEEE student member.
Yeah, one of our top members from our student RSO. So Connor, tell us about where you grew up, what got you into engineering and stuff like that.
I grew up in the area, so Rochester is like 70 miles east of here.
That's
so
in the area?
It's like
I thought he
southern
was gonna say it like with Seekers.
southern Minnesota. I mean, it's pretty close to the campus compared to some people. And I don't know, I always had an interest in taking things apart and how they worked. And then when I got into middle school, I was pretty lucky that my school had a robotics program. So I started doing that, and I kind of got into like Arduinos in middle school and kind of went from there. Like, oh, this is pretty cool. What can I do with this? And throughout high school, just kind of like working on projects and learning from people. And I kind of knew I was going to do engineering then. I didn't know what kind. I got to high school and I was like, yeah, electrical is pretty cool. A lot of things you can do with it. So.
True. So how did that work, the robotics program in your school? Like in your middle school, you said?
Yeah, there's different levels to it depending on your age. So like middle schoolers, we had what was called first Lego League. So you basically used those programmable Lego bricks to build. It was like every year there was a set of challenges. You got to build little mechanisms to go complete them. Then you programmed the brick. So it'd be like drive forward, turn, lift this bucket, that kind of thing. And then, going into high school, they have a different level that's like more technical. It's kind of like a Rector set style. So you're doing a little more assembly, wiring. And then high school is like fully fabricated. Like you get to design all the mechanical stuff. You fabricate parts in the shop. And then I even got to design circuit boards. And so there was a lot of that.
Was that Vex Robotics?
It wasn't Vex. It was, I forget exactly what it was. Might have been Vex for the middle tier. That's called FTC. FRC is like fully, you design your whole thing from like stock, like aluminum tube and plate.
Okay. Yeah.
I know that Selena was talking about working on a project like that, right? For middle schoolers, your senior design project?
Yeah. So my XRP platform is specifically to go into middle school classrooms. Have you seen the XRP? Have you seen it at all?
Mm-mm.
So, it's basically like a Raspberry Pi, but souped up. It's a Raspberry Pi Pico W, and it is sold in a kit, and it has like a 3D printed chassis with like 4 motor ports, 4 sensor ports, and then it's backed by MSU, SparkFun, DigiKey, WPI, and then a bunch of other companies. And then basically you can just use like Blockly or MicroPython to program it. And then what they want to do is they want to put it into every middle school classroom in Minnesota, because they already did that in a different state in the East Coast that's a lot smaller. Oh, Delaware. Which I feel like it's really easy to put it in every middle school classroom in Delaware because they're like half
Very
our
small,
size.
Yeah.
And so they're pushing really hard to do that here now. And then one of the big advocators for it is Dean Kamen. He's the inventor of the Segway.
Yeah, you said, I remember you mentioned this.
I met him at the Innovative Gateway last semester. They had a whole thing about it, and I got to meet him. They brought in the senator of Delaware, and then they brought in like everyone and their mom that had anything to do with anything STEM at MSU. And then like the press was all there, and yeah.
Yeah, I mean, getting exposed to science and seeing that world in a young age really like inspires you, don't you think? Because in middle school, you can be like, oh, I want to do this, I want to do this. But if you're actually like excited on working, like when you see something programmed and you're like, that spark starts, I feel like it can't really go away, don't you think?
I think, I think what was, how would I say, influential to me was that I was one of those people, at least in grade school, that was not engaged with classes. Like I didn't enjoy going. Like I do well, but I didn't really like being there. And being in a program like that, where you can actually see an application to what you're learning, or like, oh, at least if I finish my schooling, I can go work on this sort of thing.
Yeah.
It kind of motivates you. And at least like through high school, that was my thing. It was like, well, I wasn't super interested in the K through 12 classes, but then I got to do this.
Yeah.
And maybe some of those classes play into it. Like, my math teacher in high school helped out with our program. So
Yeah.
like we would actually get to like work with him a little bit. And so there was a lot of overlap that made school a little bit more engaging.
Yeah. I feel like if you get that spark in you, like especially when you're young, it's a very big deal.
Yeah, I feel like it also takes away the mindset of like, "Ugh, like I don't know how to code. I don't know how to do that. I'm just not gonna do it. Like that's way too much for me. Versus it's literally just like dragging colorful blocks and
Yeah.
making little lines with blocks. So like anyone can literally do it. And so then I brought the XRP to a middle school in New Ulm with other IEEE members, and then we had like I think they were 7th graders, and they were showing them, and they got to code it and everything. So yeah.
So Connor, how was your time transitioning from high school to college? Like freshman year, how was it?
It was pretty smooth for me just because I had known what I wanted to do for so long, and I had taken some AP classes in high school.
Mhm.
So it was more like I kind of expected what was coming. It wasn't like, whoa, college is so much different. And I was kind of lucky in that way, having known some of the fundamental stuff already. It's like it wasn't as much of a whiplash coming into the classes because the intro stuff, it's like, okay, this kind of meshes with what I've worked on in the past.
Yeah. Because I remember you in 106, we were in the same class. And yeah, like when he asked Shirk, like some question, I feel like he was the top student in that class. He used to like ask, like, I used to be sitting in the back, like, what is he talking? How does he know everything?
He's the natty of your class.
Basically, yeah. And he was asking like stuff. The professor hasn't even started. And I'm like, what is he on? Like, just kidding.
In 106 I was, but I think what I had asked him about like the power up conditions for the circuit.
I'm like, what is that? Like, because I didn't get 106. It's binary. He goes to binary and then like AND gates and flip flops. Well, I got it at the end.
Okay.
But he was in the start, like the first few weeks. Because when you're a freshman, you don't really know that many people. But I knew him. I knew his name. Like he probably didn't know my name, but he used to ask, and then the professor, like they would just go back and forth, and it's like, yeah.
I got to spoil that for you, actually. The reason why I knew a bit in 106 was because I had a high school class. It was AP.
Really?
It was digital circuits. It was called Digital Electronics.
Okay.
There's a group called PLTW, Project Lead the Way, and they do these they're like half AP courses because the college credit was only accepted at certain schools if they were in association with the program.
Okay.
And for ABET, ECET, it's like they didn't accept it for our degree, so I didn't get the credit. But I took the class.
Yeah.
So I knew like base 2 conversion. I knew some of the Boolean algebra, some of the basic like counters and stuff from my high school class. So going into something like Shirks, it's like there's some specific things that he fills in that I didn't learn. But for the most part, it was like more of a review than a new class at that point.
It is. Yeah, you can tell because also your junior design project is related to that, right? Mostly like flip-flops and stuff like that, right? Tell us about that.
We, me and Caleb and Dylan, our junior design group, we really enjoyed the digital design classes. And so junior design, senior design is a good opportunity to explore areas that you're more interested in personally, not like what the curriculum is forcing you to study. And so we wanted to do something that's like simple in principle, but just like go off the wall with it. So it's like, how about like all this digital processing, but on a massive scale? And so we designed a calculator. It's about 250 chips, 5 circuit boards. So it's a 8-bit 4-function calculator, and then it has onboard memory system. So you can store 8 bytes worth of data. You can send and load it, access the registers. And it also can hook into a computer with USB, and you can use it as a keypad or send data to Excel.
Sweet.
Have you seen that?
No,
Right,
but that sounds sick.
Like I remember when I always talked to him about their design, and from the start, like he showed me the circuit. I'm like, oh, that's interesting. And then I saw like them connected, like all the chips, bruh. Yeah, I can't wait to see that in the end. And you guys are also going to the Nexus conference, right?
Yeah, we're leaving tomorrow morning, 8 a.m. It's in Chicago, so we're gonna drive down. There's some sort of mixer Friday night, so tomorrow we want to get there for that, and then it's all day Saturday. But there's a paper competition, so we wrote a paper, a research paper about our project and like the process of development and debug. And so we are going to give a presentation at the conference, and then I think they select 2 winners. So hopefully we place.
Fingers crossed.
If not, it's a really cool experience, and we're lucky to be selected as finalists. There's a couple more groups from our school here that are going, so
Yeah.
it's a really good representation for Mankato State, our
True.
IEEE program. It's like, to go to Chicago and bring 3 groups from our
Exactly.
school is crazy. I mean, I'm really excited just to be there, and it's been fun to plan too. I've been a lot more involved with logistics and just like figuring out that whole world.
Yeah.
So
I mean, it takes a lot, but yeah. So, during your, I think freshman year or sophomore, you told me you got into a co-op, right?
mm-hmm.
So how was that? Tell us what company that is, how that process went. Because do you usually hear people getting a co-op in like sophomore year?
I don't know what a co-op is.
So,
A co-op is basically, yeah, you can say.
so a co-op is it's just an internship, but it's a longer term. So typically
Okay.
it's the summer and then a semester. So it would either be spring through summer or summer through fall.
Okay.
And mine was summer through fall. What happened was like I came into the program, I was really like proactive. I wanted to get things done. So like right when I got here as a freshman, I was emailing professors. I was like, hey, can I work on research with you? I'm interested in these areas, that kind of thing. And Dr. Winstead got back to me and was like, sure, come to this meeting. And that was something I really appreciated, was that he didn't really discriminate against like what grade you're in, not grade, but like what's your standing in the university. He was more like, oh, are you interested in work? Do you have time? And if so, here's a project for you. So I worked with him my whole freshman year, and I did 2 projects. I actually ended up as an employee of the department my second semester, so I got
Really?
paid to do it, which was cool. And I put it on my resume. So then as a freshman, I was just sending out as many resumes or applications as I could for internships, because
Yeah.
I know they don't hire freshmen usually,
Yeah.
but it's like if you apply to enough, someone will pick you up.
True.
And
True.
I had that experience on my resume already, even though I didn't work an internship. So I was able to land an interview, interviewed pretty well, and got the job. And so I worked there in 2024 from May through December. So it was about 7.5 months. Really good experience. I got incredibly lucky with it. It was just a really great group. And so I was able to work there again this previous summer and remotely throughout the year.
Mm-hmm.
And so that was at Collins Aerospace up in the cities, Southern Metro. And I was in their test engineering group. So we designed automated test systems for their products. And they do a lot of sensors for planes, commercial, military. So it would be like, here's your sensor, plug it into the test system with these cables, and then it's going to read voltages, read signals from the onboard computer. Just make sure it works. We heat them up, we freeze them, we put them in a wind tunnel, make sure everything works, in the conditions. And it was a great group. I learned a lot, but I wanted to try something a little bit different before I graduate. Because when you graduate, you kind of get not locked in, but like it's harder to move around when you're an employee as opposed to an intern. So I reached out to their design group. They do a lot of work with MEMS for their sensors.
What's that, MEMS?
So it's like fabrication on silicon wafer.
Okay.
So like, like a strain gauge, basically it's like resistors that are etched onto the silicon. We read the resistance on them with a precision instrumentation amplifier or something. And then for like example, in a pressure sensor, as the height of that, I don't know if I'm explaining this right, as the height of the wafer changes, the resistance changes because of the way it's manufactured on the die.
Okay.
And so you can actually read the resistance across the gauge carefully and determine the height of the, or not the height, the pressure on it.
Okay.
Anyway, but like you use it to make pressure sensors, you can make all sorts of stuff. So they fabricate those in-house, they design them. So I'm moving to that group now, and I'll be there this summer. So
Damn.
next month I start.
That's interesting. So before, before you started your role there, you said you worked with Dr. Winstead in your freshman year.
Yep.
What did you work on?
So he had a variety of projects, and the way he presented it was more so, here's what I'm interested in. What do you want to work on? And so
Okay.
my first one, coming back to the topic of like robotics in schools, he wanted to develop new sensors for these, the Lego Mindstorms bricks. That's what they use for FLL, the middle school robotics program. He wanted to develop a camera for it so that we could like do object recognition.
Okay.
And so that's what I did my first semester. And it was real simple. It used photocells as the pixels for detection. There was a lens that stretched the image out, and it could detect like a square or a rectangle or a circle. So I designed like a PCB for it, all of the signal processing, and it converted it into a transmission line that the brick could read, and then some simple code to interpret it. That was my first project. And then the second semester, he put me onto this rover he had from a startup in the cities. And basically they gave it to us for free to the college with the expectation that if we developed anything for it, we would give them the code. It was a startup. They didn't have a lot of resources for that. So I wrote some software for it. I wrote like a GPS navigation system with a web client. So you could basically, it would host a Wi-Fi network. You could connect your phone to the rover and enter coordinates on a map, and it would drive to that spot.
Damn.
And then I did a trailer parking system. So I built a trailer with an encoder on the pivot, and it could track the position relative to the vehicle, and it had a little kinematic system so that it could park the trailer. So you could give it a GPS coordinate and tell it, I want to park the trailer here. It would drive there, and then it would back it into the spot. And so we got to go present that at the startup in the spring, which was pretty cool. We brought a demo up there and we gave him the code, and that was the one I got paid. I mean, it was like department funding, so it wasn't like crazy money, but it was like a little bit helps with tuition, and that was really cool. That was a good project. It was funny because I told him, I was like, I'm not really into software as much as I am hardware. I told him like I can write code that works, but it's not good. And then he's like, here's a code project, It did room mapping. So I built a sensor kit that would basically generate a map of the room. So it would autonomously drive around and create data points. Then it would take the set, clean it through a filtering algorithm, and then it would actually draw a map of the room. So we showed them that too. So it was two things, GPS and room mapping. And I remember I'd be super excited about my code, and it would just be like plotting points on a graph. And Winston would be like, okay, how can we write an algorithm that approximates the app? And he would like push it into like, and I would tell him, I'd be like, I'm not really a programmer, but I think that's how he works. Like he
pushes you.
He sees you can like get into something, and he's like, how much can I get you to learn about this? And I learned a lot. I learned Python. And so I've used that like at my job and stuff too. So definitely worth it.
That's impressive. And also with Professor Winstead, he definitely does push you. Mm-hmm. It's like, it just, everyone just talks about like our controls class. It's like
exams.
I'm failing.
So is that like the field that you want to go into once you graduate? Do you want to go into like design engineering?
Definitely design engineering. I think like, what are the categories? There's design, test, quality, a few others, but I like design because you're actually making the product. And that's like, you make products and test, like you design the test system, the customer is the factory, and you deliver it and help them with it. Like it's a really cool discipline. But for me, it's like, I really want to get into that world of like, this is going to be out in the field. Like this is like, we can't walk out and fix it if it breaks. This is going to be on an aircraft. Like how can we make it as robust as possible, or whatever industry it is. Like starting out, I was kind of interested in agriculture and like maybe doing like GPS systems for John Deere or something like that. I'm really into that kind of area of like integration on vehicles,
Yeah. So you don't want to go into like the RF side, any fabrication?
I don't know. I might end up in fabrication a little bit if I stick with my current group. A lot of what we do is like, we do quality control. So like we're actually manufacturing wafers, and we need to make sure the yields are high, and we have these microscopic issues. You've got to X-ray the product, and the metal, the braze has porous. It's like there's air escaping, that kind of thing. There's a little bit of that component to it, but I don't know. It's all cool to me. It's more about like you have finite time. What is the most interesting thing that you can focus on?
Yeah. Did you register for your classes next semester?
I did. Yep.
Are you gonna take IC Lab?
I am. Yep.
Ooh, that was my favorite class. It was fun, but the labs got really long really fast. Either the lab was literally 15 minutes or canceled, or 4 hours, and we would stay past our lab time. Because everything with fabrication takes so long. And like at the end, we just made one semiconductor. That's it. And actually we didn't finish because our one of our machines is broken. And so we just got to a point where we're like, okay, we're done.
So tell us about that class, actually, because right now a lot of people are registering for classes, and there's only 8 seats in that lab, and people are asking the Professor Homari to increase it. Now 13 people are in. I wanted to take that lab.
13 people are in it?
Yes.
Did she move it to 2 days a week?
I don't know.
That's insane.
I don't know what she's gonna do, but yeah, I was gonna ask to get in, but I heard it was full, and I was like, okay, I don't. Selena was telling me it's like too hard, or like it gets. You're saying it takes
I didn't say it was hard.
Well, what did you just say right now? You were like, it's gonna.
It takes a long time.
That's what I mean. So I'm like, do I really want to go and ask if for this kind of lab? And then I see it like a week later. It's 13 people in the class. Are you in the lab?
I am. Yeah.
Oh, you got lucky.
So mine was also like that. I got in initially because my registration window was very early. One person did not get in, Ben. And so he emailed her and said, hey, like, I really want to take this class. Is it like, am I able to take it? She goes, yes, you can take it. So we did the class with 9 people, and that was it. But that lab room, there's 3 separate rooms, and plus the locker room. It gets crowded so fast because everyone is in the same area all the time. And like 2 people need to do one thing. So like, okay, you push the quartz boat into the oven. That takes max 3 people. So the rest of us were just standing around watching them. And we only have one furnace. We only have one boat. So it's just like okay, yeah, you guys do it. You guys got it. And then like you're spinning the photoresist on the wafer. Okay, one person drops it and it's spinning, and then you stop it and you take it out. You can't have 8 people do that at one time.
But it's seeing it too, like being in the room and seeing it. I feel like that's learning too, don't you think?
But yeah, I'm very surprised that she let 13 people do it, because E tried to get into the class after Ben did it, and she said no to him.
Interesting.
Yeah. But I loved that class. It was really
if there's another section that's open, I might get in, because I
think she should move it to 2 days a week.
Yeah. But
our TA had to do a lot of side work, like when we were not there, of like, like one time we messed up our etching, and he had to redo it like 5 times outside of lab. And so we did not have lab the next week because they still could not figure out the ratio and the time wise for it. And so then they just kept redoing it on like one wafer until they got it. And they were like, okay, like come back to lab and we're going to do it this way. I mean, we all did it that way. And then our wafers were very unique.
How advanced is like the teaching here? Because we always hear, like semiconductor industry in Taiwan is like way ahead from like America, and they want to like. And I'm not saying it's that advanced, but I'm just saying, in your opinion.
In my opinion,
like,
I think that even if you go to the U of M,
I think it's pretty cool that we have a clean room. I'll say that.
Yeah.
Because
I will say, yeah.
A lot of like smaller, I mean, we're a pretty big school, but like a lot of like accredited EE programs don't have a clean room. And that's one thing I've told people at work. Like And they're like, oh, MNSU Mankato's EE program? And I'm like, yeah, we have a clean room. And they're like, oh, really? You know? And so I think that's,
Yeah.
even though it's like not as high a resolution as like some clean rooms in universities, it's like, it's pretty cool to have the opportunity to take that class.
Yeah, I'm not like throwing shade on. I'm not throwing shade on MSU or anything. I'm just curious, because there's gonna be a push right now, like in the coming years, to build fabs here, like put engineers here, then people are qualified, because like it's in high demand. So that's why I just wanted a reference, because I haven't taken the class. That's why I just asked you.
Yeah, because I personally don't think that what I've gone through has gotten me ready for like actually having a job. Like I've had to do a lot of like actually learning generator and like electrical theory at work, and like seeing it in front of me and seeing the application, and then like like this is where the formula came from when I just like erased it from my notebook 2 semesters ago, and like that's not important, flip the page. But like I
I mean, that's the case for a lot of things.
yeah.
Like for EMAGs, we're learning it, but like you said, when you got into your job, but yeah, I'm just curious.
But like I do understand about how like wide range EE is, that you can't especially like hone in on one like subsection to highly train students on that if not everyone's going to go into that field.
Yeah, and you also need a master's. Like usually, if you want to get into these industries, like they want like it's better to have a master's degree if you're like serious about it.
Yeah, I think a lot of companies in engineering will pay you to go back for your master's. I don't think it's necessarily needed for like entry level jobs. I don't think it's like psychology. You need a master's for that. You know, you can't practice without a master's. But you can obviously get a job without master's in EE.
Yeah.
Most larger companies, like I know my company, they do offer like full tuition compensation. That's kind of one thing I'm looking at is like, hey, as long as you can justify your degree for the business, like, oh, this is why this is going to help me as an engineer, they'll just give you 100% tuition reimbursement, like there's strings attached, like at least I know my policy is you have to work there for every year that you were in school after you finish your degree or pay back the tuition.
Oh, okay.
That's mine is. So like if I do a master's in 2 years or 3 years, I have to work there that much time.
But you'll still get paid, right?
Yeah.
The same
Oh
amount.
yeah. Oh yeah. And the cool thing, at least at my group, is that they give you 3 hours a week of study time. So technically you're on salary. You could work a 37-hour work week and you're going to get your full salary, and they're comping you for 3 hours to like go home and study your classes.
Yeah. So during your co-op, you're also like going a full-time student and then still getting paid too, right?
Yeah. Well, that tuition program is only for graduates. So
but like as an undergraduate.
Co-op was pretty rough because I did it after my freshman year, and there's a lot of core classes your sophomore year. So I didn't want to be behind. What I did is I took Physics 2 online over the summer while I was working. And then I took Circuit Analysis 1 and one of my generals in the fall. And I did Circuits 1. It was a Friday class. It was like 6 hours.
Oh,
so
my God.
You basically went there in the afternoon. You were there for a 4-hour lecture and a 2-hour lab every Friday.
Wow.
And it was in St. Paul. And my commute to work was an hour because I didn't relocate for my co-op. So I would drive an hour to work, and then I would drive 45 minutes to St. Paul, 6-hour class, and then an hour and a half home every Friday in the fall. It was
called dedication.
It was awful, but it was so nice because I did not fall behind. I was ahead on my math because I'd taken Calc 1 in high school. So I just slotted into the track, and then I had one of my generals done. So I'm only back one class. I need to take digital design, and that'll be this fall. But after that, I'm totally caught up from the co-op.
Yeah, I remember like when we were sophomores, I thought you transferred school or something like to a better school or something.
No, I felt bad leaving. I was like, because I was in IEEE my freshman year, both semesters. I felt bad leaving, but it was like, I thought about it for a while. I was like, I want to do this opportunity. I'm only going to do it if I can't fall behind. They say like, oh, you're not behind, you know, you're just, some people take, but then when your classes are only offered once a year,
Yeah.
you are behind.
Yeah.
Like if I missed that semester and I didn't do that, I wouldn't have been able to take all those classes.
True. Because if you miss, I think physics 2, you can't take circuits. If you can't take circuits, you can't take
Yeah. And then like, I know at least when you get to senior year, it's like the classes are structured such that there's one session and all the times line up.
Yeah.
But if you can't take one of those classes, there's no alternate. So it's like, or if you take a bonus class, like I'm doing the math degree,
Yeah.
I'm sure like Nati's had the same issue where like this math class that I need to take is in the middle of the CE class I need.
Yeah.
So now I have to pick, like, do I, and I'm.
Yeah, I'm going through that too because I'm also double majoring, and like you see it with computer and electrical, it's most of them, they're aligned, or one elective, like you could take a normal class for computer engineering, like a needed class, and it could be an elective for electrical engineering, so you can cross them out. But like I get what you mean, but you're gonna have to, like, every semester is gonna be like 18 or 19 or 20 credits because you can't. I haven't taken anything less than 17 credits, I think.
Yeah.
This is my first semester where I have such a light load. I'm only taking 12 credits, and I know it's amazing. And I'm just gonna rub it in your face, guys. And
Let's hear it.
and like 3 of my credits are fake. So
Wait, what does that mean?
they are for my internship.
Oh yeah.
But I don't have an internship. I have an actual job. And so I was signed up for Powers with Winstead, but I personally don't like Winstead as a teacher. And so I really did not want to take it. It would be really helpful with like generators and everything, but I really did not want to take it. So then I did the internship credit instead, and I did that for 3 credit hours, and then I'm doing my art history class.
Which is so challenging, right?
It's
Always talking about it.
It's just a bunch of busy work. Like, it blows my mind what is expected of this class because I have not had this low effort of a class so far. Just Monday, I took my first 0 on a homework assignment just because I didn't do it.
Why? Why are you slacking?
9 credits and you're slacking? That's crazy.
Yeah. I haven't missed the homework.
1 credit is my senior design, and then the rest is for my PLC class, which I love that class. Any class, my IC, I think PLC is my favorite, and then IC, and then digital logic, and then 106. But PLC, I love that it's so hands-on. There's no lecture. It's all of it is in the PLC lab, the automation lab. And like everything, I don't know if this is what it's like being smart, but like everything just makes sense. Like I've not had to like study outside of class. Like we had an exam, and I was like, oh, like I'm not even gonna study anything for this exam because it's just logic. It's just like common sense of like, okay, like you want the light to turn on, then have the light as the output and have this button as the input, and then like, oh, you want that in like for certain conditions, so then just build the logic for it. I love it.
I mean, you don't want to offend other people, because other people, if you talk about engineering,
no, because people are struggling in that class, and it blows my mind.
Well, not even that. People that are not in engineering, if they hear you say like stuff like that, they will get offended, I feel like.
At what?
Like, how you think it's so easy and everything.
Oh,
Well, I think
whatever.
it's specific to certain people. Like there's classes I'm taking right now that are like, this one is super easy. This one is impossible. They make you feel stupid, like control systems.
Yeah.
Like I've taken like some, like solid state was a little rough. Like there was some rough exams, but it's like, this is the first class where I'm just like, I'm not getting
controls.
It. Yes. Yeah, I'm not getting it.
You don't know
what
to expect.
I take that back. I'm sorry.
You don't know what to expect. Like you have to be like ready, like for anything. Because like I remember for example, electronics 1, it could it's gonna be hard, but if you study for it, like you just gotta know how to solve for this kind of like MOSFET, for example. If the resistor is here, capacitor is here. How do I solve it? And then you practice and then you're like just changing the numbers or whatever. But this one, it could be something about, I don't like transfer function for this. And you're like, okay, I know how to work with transfer functions, but I don't know what he might ask. And in the question, it's just like, I don't know. I always struggle.
Yeah, I understand that because like Winstead, he teaches this, he lectures this, homework's on this. Okay, lecture, homework, understandable. Exam,
It's just different. I don't think it's hard though. I don't think the questions, they're not hard. Like it's just you gotta know how to approach it. I feel like as soon as you
either
see
got
it,
it or you don't. That's the
yeah.
thing.
As soon as you see it, you have to know like how to approach it. And if you have that angle, if you see it, you can solve. You're like
Yeah.
3 points or whatever, or it's just 0 points. You can't work through. That's my experience. Usually, I get like, oh, this is what it's asking, bam, and the other questions just I don't know.
I actually spoke to him about his exams at one point. And his position was, because I told him, I was like, I feel like the content on the exam is kind of tangential to what you have on the homework or teach. It's like, I got really good at doing this because I studied the homework and the lecture notes. But then like something, you look at the question, it's not inherently hard. It's like, oh, I should know how to do this.
Yeah.
But I just don't know how to approach it. And
Yeah.
what he had described to me was that he structures his exams in a way that students who really understand his material and have a little bit of that like engineering aptitude can like work through it. Like, oh, I kind of understand what he's asking for. I know how to do these things. Let me see if I can develop a process to solve it. You know, so and he says the way he structures them is so that he can see like these students who end up on the higher part of the curve, they really know how to figure it out.
Yeah.
And the average is really low, but it's like, okay, you're just taking the class to take it. And then these kids are failing. So it's like, I kind of get like, it's interesting, his approach. Like it's more like analytical, like let me analyze but like to me as a undergrad student and not a grad student, I just want to understand the fundamentals well and be able to pass the class. It's like, there's so much focus, not to get too far into the specifics of a class, but like there's so much focus on like analyzing the transfer function of a system. And it's like, I don't even understand how to implement this system. Like, how do I put a PID controller into my robot and tune it? You know, that's what I want to know. That's what I'm going to use. I maybe don't care exactly what the trajectory of a pole is on the transfer function. You know what I mean? It's like, it's cool. It's like, it's okay. Someone might need to know this, but that's maybe a grad student who's going into the controls industry. You know, that's kind of my position.
Yeah. He also asked me like, what do you think about the exam? And that's the exact same thing I said. I feel like you give very good, like very easy exam. Like they look like they're easy questions. I either know exactly how to do it or it's just like I'm lost. And he's like, but I said, I don't think you make hard, like, because everyone's saying those exams are hard. And it's just like how you see like how exams should be is like, they should test us. You know, we shouldn't be expecting the same question for the exam and then just doing it. Like a curveball isn't a bad thing. And especially he said to me, in the real world, I mean, you can get help, but sometimes it's just like, you don't know what's coming at you. So it's not that bad. And also like how much, like everyone's so much obsessed with their grades, I feel like, and he doesn't care about grades. So like, because you could be getting like the average, which is very low, like 40% is the average, but you can get a B or a C, you know. But like some people, they're like too obsessed with their grades, and it just gets to you, and it's just like a downward spiral. I'm looking at the results. I'm like, oh, that's good enough, you know.
Yeah, I mean, my thought process is, did I get over 50%? Oh no, I didn't. Am I above the average? Yeah, I'm fine then.
Yeah, that's not too bad.
I think there's two angles. It's like either, oh, I'm doing really terrible on these tests. I hate this professor. I hate this class. I'm just gonna, you know. But then there's an angle of like, oh, I'm doing really bad. Maybe I should like look closer at the material, try to understand it more.
Exactly.
You know, it's hard because like people don't have time. Like I'm doing 20 credits this semester, so it's like I don't really have time to like crack open the textbook and look at it.
Yeah.
But at the same time, it's like you know, when you see those questions that aren't necessarily hard, but
Yeah.
you should know, it's like, man, I should know how to do this. I'm taking control systems. This
Yeah.
is a controls
But
question.
it's not even a time thing. I feel like you can put in so much time, like reading the material, and still, I don't know, like you just got to find an approach. Because I know some people, they're getting like 100% on the exam, 100%. And you're like, we're in the same class. I'm sure they're going through the same degree, but like, what do they put in? And I don't think it's more time. I think just changing your approach, because I've seen that improvement. My first exam was like very low, and then I just kept getting better. I remember you said, "Oh, it's gonna get down." Remember when we were talking about controls?
Yeah.
And I genuinely, like, I changed my approach on studying for that exam,
That's
and
good.
it just got better. So, and I see other people getting like good grades. I'm like, that's possible. You know, that's what, like, the exam isn't hard. Like some exams, no one gets above 80, but someone gets 100%. You're like, it's possible.
It's going down for me, sir. All right. No, it's funny because like the first exam, I was like, oh, I knew that was a wash. Second exam, I was like, I totally failed that. I did a lot better. I was like, really?
Yeah.
Third exam, I was like, I did pretty good. And it was,
It's
that's
always
my drop.
It's always the exams where you're like, oh, I did absolute like shit on that. I
Yeah.
know I did. Get back 90%,
Yeah.
and then you're the ones that like yeah, like I did so good on that one. I got it. I'm confident. 20%.
Yeah.
Like I had a quiz in electronics last semester with Hamari, and I think I walked out, I was like, yeah, that was really solid. And then it was in the grade book. It was a 1 out of 10.
Oh no.
And I was like, I thought I aced it. I was like, I got to email her. That must be wrong. So I emailed her. I still have the email somewhere. I was like, hi, Dr. Hamari. Is this the correct grade? Did you put this in? And she was like, yes, I'm sorry. I think she put a sad face. She's like, you just didn't get the concept. So I was like, really?
The sad face is hilarious.
No, she's great. I'm really excited for IC Fab next year and VLSI because it's like, I think Hamari I didn't have her till my junior year, but she's a really solid professor.
Yeah.
Like Electronics 1 is such a fundamental
It's just
class.
the whole time you're not slacking. You can't slack off. It's like a homework, a quiz, an exam, a homework, a quiz. Like you just don't rest, which is in the end it's good. But yeah, me too.
You really learn it though. Like how to build a transistor amplifier. It's like she focuses on like how to actually apply the information, how to calculate the values. Some professors I've had, it's just like, why are you focusing on this? You know, how do I apply it? You know,
Yeah.
she's actually like practical,
And
which
yeah, also she used to teach solid states, and when she came to electronics, it was a solid states exam, like not exam but lesson. She taught us how to I don't know if other professors did it, but like a MOSFET, for example, it was a solid states lesson.
Yeah.
Like I don't know if that's the case for all the time.
So I think my electronics 1 was a very weird class. It was taught by Jay-Z. I think I can confidently say I should not have passed that class. Very confidently. Because I feel like what he focused on, he like kind of like brushed past everything that when we got to electronics 2, Hamari's like, oh, like, okay, like I'm trying to gauge where you guys are at. Like, did you talk about this? We're like, yeah, like we did that for like a week. She goes, only a week? And then she did like 2 months on that. And like, oh, like this is very important. And Jay-Z just like, oh yeah, like that's a topic. Next. And like, so that's why I think it was good that Hamari moved to electronics 1. And then I heard that is she teaching electronics 2?
No, it's Wu, right? Professor
it's
Wu.
woo. Yeah.
Okay. Yeah.
Yeah, we had that same experience last semester. We'd go to her office for help with solid state because she switched from solid state, and she'd be like, "You focusing on this right now?"
Exactly. Yeah.
It was really nice actually that she covered solid state and electronics 1 because we took electronics 1 and solid state together. So like the content in solid state was reinforced by the electronics component.
Yeah.
You kind of like understood
it should have been the other way. It should have been like your solid states would reinforce your electronics, because but I mean how she went with it is we got into BJTs and MOSFETs in the beginning, and she went to the op amps in the end, but which should have been like op amps, and that's how it should have been, like the units in the textbook.
Yeah.
But she just went all around, and like halfway through the semester, we're in solid states, we're learning about MOSFETs, and like, oh yeah, like I get it, like a gate, this and that, you know. But yeah, it was a good. I really enjoyed electronics 1 too. So we talked a lot about academics. Let's see what you like to do like outside of class. And like you said, you're taking like all these credits, but what do you do for fun, stuff like that?
A couple of things, I guess, like right now in this semester, it's just been school because we're getting ready for the projects. But
Yeah.
I'm really into music. I've played piano for a number of years. I actually was competitive in high school. I went to competitions and
Wow.
stuff, classical. It was a lot of fun, but I got to college. I took lessons my first semester and then didn't have time anymore.
Yeah.
So I just kind of play for fun sometimes.
You got to see it.
But it's good to de-stress when you do all this analytical work and school. It's like it's nice to do something that's creative in a natural way. It's like, just playing around with an instrument and being able to de-stress. I'm also into like outdoors activity. Like I go hiking, backpacking.
Wow, really?
I'm actually going to the Badlands in May, so we're going to do a week-long trip through there. And the interesting thing about them as a national park is that they allow you to just camp out.
Anywhere?
Just walk out into the park. So we're going to go park our car, and then we're just going to walk out for a week.
Are you just going with friends or
I
alone?
might join you.
Yeah. Oh,
if
yeah,
you invite me.
You can. Yeah, we got seats. might be a little
yeah.
awkward because it's some of my high school friends. But yeah, it's going to be fun. We're going to pack for the week, bring like GPS and stuff so we don't get lost.
Mhm.
I like to do that every year after school as a de-stressor. It's
Yeah.
a transition before the job for the summer.
Yeah.
So like the last 2 years I've gone to Michigan. I used to have a pop-up camper that I would bring. So I would haul a bunch of friends up and we'd stay in the woods for a weekend, just like by ourselves. No one's out. But yeah, that thing broke last summer.
Oh,
So
no, really?
that's why I got into backpacking. I was like, I don't want to buy another one right now. It's just,
You can get a cheap pop-up on Marketplace.
Oh,
I've checked
looking.
them out.
I see them in class. They're looking for campers.
well, you can get one. The trouble in this, the roofs rot out after about 4 to 5 years.
Yeah.
So by the time mine broke, the cable broke that lifts it, the entire roof was rotted to where it would bow out when you crank up. I had
Oh.
wood shimmed around. I had steel brackets, and they're just built poorly. So it's like getting into it is kind of an investment of your time. It's like
Yeah.
I'm gonna have to fix this every year.
Yeah. But I mean, you said you can do backpacking, but yeah.
Yeah.
I'm really into like camping too, like going out, stuff like that. Like for spring break, me and my friends, we went to Colorado, the Rocky Mountains.
Yeah, beautiful camping. I've been there
my
too.
God, yeah, but it was like when we went, it was a crazy story because there was like when we were on our way there, when we were almost in Colorado, we got a fire warning. Like you can't, like there's a fire warning. It's very low humidity, high wind, no fires, and we're going camping, and we're like, oh no. But okay, we'll make it work at least. And then we went to our camp. We went to our campsite. We were like, it's not too bad, but it was windy. It was getting windy. And then it just kept getting worse and worse. And oh my God, our tent was a 12 people tent. We were like,
That's
it was
massive.
It was
tent.
a big tent, yeah. But we were only 6, but like whatever. But the wind was messing it up. Like the whole night, I couldn't sleep. My friends were sleeping. I was like, I can't sleep. I can't sleep because this thing is gonna collapse. Oh my God, that was a hell. But yeah, that tent broke, so we're gonna have to get a new tent. But it's like going out in nature. It's such a relief for me too. Like I can really relate to what you're saying about that.
Yeah, I seen you in class and lecture looking at campsites.
Yeah, before, yeah, because it was this year. Because we sit together in EMAGs and electronics. Like sometimes I'm just like, I don't want to listen to this anymore, and I just open my phone to look at. Because it's a struggle when you're out in the spring. It's very hard to get campsites, but in the summer, I was thinking about that too. Going to Badlands, I was telling my friends, hopefully they'll say yes.
You should go.
Yeah.
You got to go. Early May is like the very beginning of the season. No one is ever out.
Yeah.
If you go camping early May, you can always find stuff where you're just like last summer in Michigan, we went to it. It was an entire campground on a lake, just in the woods, like way out in the UP. We were alone.
Yeah.
We were the only people there. Every single campsite was empty. And it was just like you could sit outside and listen to the lake. And it was just like quiet.
Yeah. I mean, right after, like, as I only have 1 week until I start my internship.
Mhm.
So it's like finish, and that week hopefully will make it work. But
Yeah, that's the one I'm doing. I think we're leaving the 13th. It's a Wednesday because my buddy has class still. But
Oh,
yeah, I start on the 18th. So
yeah, me too.
I'm working before that too in early May. But I transition to my new group. It's an internal thing, so it's like I will work in the test group one day and then the design the next.
Oh, so you're still in the test group.
I am now. Yeah,
Okay.
I still work there part time. So
Okay.
I'll drive up every few weeks. I'll go up for a day and then remotely I'll work like 5-10 hours. But then, yeah, I'll probably work a few days in person in May. And then the 18th, I transition to my new group and move over there. But yeah, the few days before that, like right up until the 17th, we're going to be in the Badlands and then drive back the day before.
We might meet up.
We should.
I have your number, so we might meet up.
Yeah, let me know if you're there. We can
Yeah.
do like some kind of group thing
We
so
should.
we don't get lost.
I mean, you're serious. I don't know what my friends are gonna do, but your friends, you look serious. So
We got serious kit. I mean, when my trailer broke, I did a pretty good job of partying it out. Like I tore out the electrical, I tore the AC off the roof, and I basically made a good bit of money like partying it out to buy my backpacking rig.
Oh, nice.
And I got everything on. There's a particular group of people like on Marketplace who buy backpacking gear, decide they don't want to do it, and then sell it. So it's like brand new, but you pay the used price.
Okay.
So I got like probably like $1,500 worth of gear for like $600-700.
Jesus Christ, damn.
And it was like this one guy I went to, he had like this big mansion and it was a $350 sleeping bag.
Oh my god.
He had never used it. It was brand new. And he goes, yeah, I threw out my hip. My wife wouldn't let me go.
Oh,
And so I bought it off.
that's
Yeah.
That's the way to
Threw
do
out
it.
his hip.
Yeah.
Just never went.
Yeah.
you probably never.
No, it was brand new. I was like, I'll take it. So
It's like the people that are selling like their treadmill on Marketplace. Brand new, still in the box.
Yeah.
But that's the way to do it. Don't ever buy new. I mean, there's things you should buy new.
Yeah.
Like I got the, REI in the cities. It's a big outdoors outlet. I got their credit card and it does 1.5% cash back for their store. So I put my tuition on it.
Whoa.
Yeah.
I
I put
funnel
my-
it.
I put my tuition on my Discover credit card, and so I get like, I think I get 3% back on it.
Oh, yeah,
And
I do that too.
That's good, especially when I'm paying like thousands of dollars,
Mhm.
and I
Yeah.
just pay it off right away. So it's all good.
But
Yeah.
you gotta funnel it. If you charge too close to your credit score, your credit limit, your score goes down.
Yeah.
Yeah.
So I did it in increments of like $600 for like an
Oh.
entire month.
Engineers
Just like-
engineers think
what is your
alike.
limit?
4,000 on that
Okay.
one.
Yeah.
So I think it's like you don't want to exceed 20% of your limit.
Yeah.
something
I do
like
I
that.
do 1,000. I have 3K balance on my Discover. I do 1,000, pay it off, 1,000, pay it off. I don't
Yeah.
think 30% isn't that bad on credit cards.
Yeah.
If you get above that, maybe.
Yeah.
Yeah, but it's,
That's interesting. So I was gonna ask mostly about so you're interested in like you've been part of the IEEE RSO for like all your time, 3 years.
Yeah.
And you're running for the vice chair, right?
Mhm.
For next year.
that's right.
So how are you approaching it? What are you feeling about it?
What are some strats?
Well, my approach to the position is how can I leverage what I know from my own experience to help other students? Because I have seen a lot of kids who choose EE or CE with no other experience. Like they never did a program, they didn't really learn about it, and they don't know these fundamental things like how to program a microcontroller or use a multimeter. And I was very fortunate to have the experience I did to where I was able to get internships and do research and all this. But I have a lot of insight now. I mean, I've actually like helped out with reviewing candidates for interviews at my work and things like that. So like I do have kind of an inside view of like what do we actually need to know. And I feel like if somebody came to me and was like, hey, how can I get an internship? I would be able to give them a pretty good idea of like, oh, you need to change your resume to this. Here's how you do it. So anyway, regarding IEEE, I think I would be a pretty good resource on the board as somebody who has proven like, here's how you can get into the industry and do these things to maybe like run workshops or do one-on-one.
Yeah.
So what was the drive between doing vice chair versus like, project coordinator?
Project coordinator.
The one that sets up technical workshops.
Yeah.
Well, I wanted to be more involved with the overall function of the program
Okay.
because, well, there's like the mentoring piece, but then I also enjoyed like the logistics of like choosing events and doing some of that PR, like communicating with other chapters and members of the community. And so it was like I thought it'd be more interesting to me to be vice chair than like one of the other board positions.
Yeah. Yeah. And, before we all three of us, we went to Las Vegas for the Rising Star.
Mm-hmm.
I saw the value in IEEE before, but like during that conference, my eyes were really opened up because IEEE has, even after you graduate, like a young professionals group, like in your city, and like it's a very resourceful thing, which a lot of EE students, like freshmen and sophomores, and even juniors too, like they don't utilize. I mean, I don't think it's a being ignorant thing. I think it's just like not knowing enough, like how much you can excel, like by being a part of this organization, by like having leadership roles, but not even that, being part of the club. You don't have to be a leader, just like going to events, talking with, like seeing the resources online, going to like the Rising Star conference, for example. That's where I got exposed to like the recruiter for the internship that I'm going to, and talking to like the other presidents, what other RSOs are doing, and getting inspired. It's a resource that I feel like a lot of students should like be part of and benefit from. So for next year, like the next year's board, I feel like we really got to work on that. So like having someone like you especially could benefit a lot, in my opinion.
I want to mention too, a couple of things I took from the conference. I was really proud of our representation of our school.
Yeah.
We were probably in the top 5 for like most members.
Top three.
Yeah,
three.
It was
Like,
crazy.
We had 14 people, and there were these were big schools. This was like
Like
Texas
UCLA.
A&M.
UCLA.
There was
UCLA,
MIT, and they only brought like 2-3 people. I couldn't believe it. And our chapter, we had 14 kids. I'm not even on the board. So it's like, just to go as a student member, when everyone's like, oh, what board position are you? And I go, I'm just here as a student member. They were surprised.
Yeah.
And
for
it was
free,
covered.
for
Yeah.
free too.
Yeah.
Yeah.
The other people had to pay the students themselves.
Yeah.
Blew my mind.
I also, I had this misconception going into it that IEEE was more of an undergrad thing. And I met a lot of like members who were YPs or
Yes. Yeah.
these are people who are like engineer 1, or they're getting into their industry and they're still attending events and they're expanding their network. And I was able to connect with some of them, and it's cool to see like some of them on LinkedIn, they'll post like sitting down for dinner with like grad students from this university, through IEEE. It's cool to see like this community of professionals outside of the workplace that are still like collaborating on projects and writing papers. And I didn't know that was the experience. I had felt like IEEE was like an undergrad RSO.
Yeah.
Like it's something you do while you're getting your degree.
Yeah. Yeah. I did. Yeah. The same thing for me. And it's great to see these people like after their like after their degree, seeing them, like asking them. It's like you can learn a lot because you get lost in this degree, like you're taking all these classes, you're struggling, some classes you're failing, but I mean, you're just going through it, and seeing that it was a very inspirational thing, like for me. And yeah, I would really like not just appreciate IEEE, but I want other students to get exposed to this too.
And we did not gamble.
Yeah. I mean, you're under 21, so
Yeah, it's
actually,
not
we did
legal.
not,
It's
yeah.
not possible.
yeah. I mean, me and Selena, did we gamble?
So what I was gonna say when we were asked you about like what you do in your free time, I thought you were just gonna say like hit the slots in your room or something with your machine.
Yeah.
Yeah, that was okay. The thing is, I didn't gamble, but I got kicked out of the casino.
I remember.
which I thought was.
I felt so bad about that.
I thought that was stupid because the casino is in our hotel.
Yeah.
So it's
Yeah.
like, how can I go to my hotel room without being
You can't
in the
pass
casino?
through it.
And I was watching Yobster on the table, or maybe I was watching someone else on the table, And then they just come in and be like, where's your ID? Where's your ID?
Yeah.
And I thought she was asking me for like a drink or something. I was like, no, I'm good. And then they're like, I'm going to get security. We're going to kick you out. And I was like, okay, I'll go to my room. But no, and I got back and I was like kind of bummed. So I went on Marketplace. I was like, well, there's slot machines on here. They're pretty cheap. You can get one for like $150.
So that's where your inspiration came from for our casino night?
Yeah, well, I wanted to do the casino night because when we were in Vegas, I was like thinking about, it's like, oh, look at all these casinos and look at IEEE. I was like, how can we bring this together, and bring it back to our group? I think that was the core idea there. And then I don't know, I've always wanted to get a slot. They're kind of cool, you know. It's like as an engineering student, you're into like the electromechanical stuff. That's why I've kind of been into RVs. It's like these like self-contained systems are pretty neat. All the reels and lights and so like just cool things to pick up, I guess.
I'm so happy like you brought that up. You also, we were talking about this like a month ago, I think. You told me, you showed me your ping pong machine.
Pinball machine?
Yeah.
Yeah.
How like tell us about that. How did you start building that?
That was in high school. Senior year of high school, I started making that. And it was essentially just, I was sitting one day, I was like, I want to build a pinball machine. So I started working on it. And my grandpa, he was a manufacturing engineer. So he has like a whole shop at his house.
Mm-hmm.
And so I knew he could do the woodworking with me. So I designed the whole thing in CAD. We went and built the frame of it out of wood and painted it. And then I had to do the electrical, which is all the play field, all the mechanisms. And I thought it was just a fun project. Like I designed each one in CAD. I 3D printed or machined it, built it, I wired it. And there was scope creep. It ended up being a 3-year project, and it's still not like fully complete. Like it's buggy. It hasn't been fully programmed, but it's just kind of like something I like to tinker with. You know, it's like every 6 months I'll come back to it and add a mechanism to it or something.
Yeah. You invited me to your house. I'm going to come one day.
You should. I mean, it's, you could see it. It's pretty cool. I could like send you some videos or something.
No, you showed it to me. I was so impressed because you told me like you made everything, like every component, you like 3D designed it and everything.
I wrap my own solenoids. The ball return is all homemade. I mean, I don't know. There's a couple things I ended up buying because it's like you throw enough attempts at a mechanism, it's not working smoothly. Like the pop bumpers, the ones the ball hits, it goes bump, 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 bump. They have a pressure plate. So it's a 360-degree plate, and it sits on a pivoting switch. It's like a super high precision part. Like it's so easy to hair trigger it to where like the solenoid will just get stuck down and start on fire. And I tried for like 6 months to make one and I couldn't. So I just went and bought it, but no, it's bringing it like into a broad sense. It's like those sorts of projects that you can just like tinker with on your free time. It's helped me a lot as an engineering student. Like for example, when I took 106, I came home that weekend and I built a target bank with SR latches. So it was like, it would latch, it used digital logic. It would send like a single pulse to the computer for like a target hit and a lawn pulse for the whole bank full. So you could take your score counting on a digital line. And it's like being able to like learn it in lecture, like just the theory. And then like, I'm going to actually go do a project. And like, now I'm asserted with it. Like, I know how to do this. It was so helpful for me to like solidify the lecture and not forget it.
Yeah. And your case is also rare. I've talked to different, but like it's the experience for me. I knew I wanted to get into engineering, but like I couldn't decide what to get into. And I started with computer engineering, which I added electrical engineering because most of like the things. But as I got in, I was exposed to it, and like I got better. Like obviously you learn math, science in high school, but like during my college year, it was learning it, and it was like a linear thing, like not unlike you, which you said you were interested in electrical engineering in high school, and like you did all these things. Like I don't know if you were like directly thinking about, oh, this will help me, but my point is, I went all around. My point was, like, what would you tell someone, like, from your experience, someone that's in middle school or in high school that are thinking about getting into electrical engineering? Like, from your experience, what are things, you might have talked about it right now, but what are things that they could do or should do that will help them get advanced in this degree?
The biggest thing, and it sounds generic because it's most true, is you got to do projects. I mean, like for me, an Arduino kit is like $35. Like you can buy it and you're going to learn how to program. You're going to learn how to do basic electronics. Nowadays, you can order a circuit board for like $15 and have it manufactured. There's so much free software. It's like you can learn 3D modeling. There's all kinds of student licenses, order boards. It's like you just got to get into it. And then you're going to learn like, oh, I started this on fire. I blew up this component. Or like I ordered a board and the corner cut me. So maybe I should put rounded corners on my boards. You know, it's like you can't really learn that from like a video or a book, or at least you're not going to remember it. And for me, it's like I did so many projects. Like when I was in 7th grade, there was a design project we got to do for the robot. Like it came with it's hard to explain. It's like you do the Lego thing and they have a project portion where you do like a separate thing that's not Legos. And I got to like design a system and make a circuit board. And like, that was my first time learning that. And it wasn't great, you know, but it was like semi-functional and you kind of learn what works and what doesn't. One other thing that helped me specifically, this is kind of niche. We went to the public library a lot when I was growing up, because it's like there was a period where like that was kind of what we did after school, is we would go to the library and like look at books, you know. And so I would just I liked robots. I thought they were cool. So I would like go find books with robots on the cover. And I read a lot of textbooks on like hydraulics and pneumatics, or like, I remember one specifically that was like the most influential as a young kid. It was like, how to build a robot for beginners or something. And the whole book was about this guy building a line following robot inside of a Tupperware container. So it was like 2 little motors for the wheels, 2 photo cells for the sides, and then it was like some kind of op amp trigger and transistors. And so each chapter was one component, and he would introduce it, and then he would basically say how he's integrating it into his design. And then by the end of the book, he builds it. And I remember that was so big for me because it was like actually learning like the fundamental components and how to use them. And I would like reread the chapter on the transistor because I didn't get that one. And that was a big part for me, was like reading books, doing projects. You know, that's the best way to learn, in my opinion.
Yeah. Well, thanks for the advice to the young kids and us too. I feel like I've learned a lot from you.
Yeah, I feel like I am a crappy student compared to you.
I don't know. You haven't seen my test grades, so.
I mean, it doesn't really matter.
Well, do you do your homework?
Most of the time, you know.
Last week we had Charles on. We found out that Charles did not do a single sheet of homework.
Religiously. He said
he does not believe in homework.
I can see it. No, I'm just kidding.
But
Yeah.
Connor, thank you so much for coming on. And we hope to see you more on our board next year.
If I win it, we got to see. We got to wait for the election.
We'll see.
Yeah.
Go vote. Go to your local IEEE Mankato chapter office and vote.
April 21st, right?
Put the ballots in.
Yeah.
So.
But yeah, thank you for coming. And
yeah, thanks for having me. It's fun.
all right.